Download this code from codegive.com, link in the description below. Data Contracts Experts Panel AMA, a deep dive with code examples. This tutorial will explore the concept of data contracts, discuss its benefits and challenges, and guide you through creating and implementing data contracts using various approaches, culminating in a virtual experts panel AMA scenario where we address common questions and concerns. What are data contracts? At its core, a data contract is a formal agreement between data producers, those creating and publishing data, and data consumers, those using and relying on that data, that defines the structure, types, and quality expectations of the data being exchanged. It's like a service-level agreement, SLA, for data, but instead of focusing on uptime and response times, it focuses on the data itself. Think of it like this: you're buying a car. You have an expectation that it will have certain features: wheels, engine, steering wheel, operate within a certain performance range, mpg, horsepower, and adhere to certain safety standards. The manufacturer provides a specification sheet, that's analogous to a data contract. It defines what you can expect, and you have recourse if those expectations aren't met. Why use data contracts? Data contracts address several critical challenges in modern data ecosystems. Improved data quality by explicitly defining expected data types, formats, constraints, and even validation rules, data contracts help ensure that data adheres to a consistent standard, minimizing errors and inconsistencies. Reduced data engineering costs. When consumers know precisely what to expect from a data source, they can build more robust and efficient data pipelines. Less time is spent on data cleaning, transformation, and debugging due to unexpected data changes. Enhanced data trust and reliability. Confidence in the data is paramount. Data contracts instill trust by providing a clear, documented agreement about the data's characteristics, leading to better decision-making based on reliable information. Better data governance and compliance. Data contracts contribute to better data governance by enforcing data standards and ensuring compliance with regulations, example GDPR, HIPAA, that mandate data quality and security. Enables schema evolution with backward compatibility. A well-defined data contract enables producers to evolve the data schema while maintaining backward compatibility for consumers. This minimizes disruption to downstream processes. Facilitates data discovery and understanding. A data contract serves as a valuable source of documentation for data consumers, helping them understand the structure, meaning, and limitations of the data. Key components of a data contract. A robust data contract typically includes the following elements. Schema definition. Specifies the structure of the data, including field names, data types, and nesting levels. This can be represented using various formats like JSON schema, Avro schema, protocol buffers, or even a well-defined database schema. Data types. Precisely defines the data types for each field, example string, integer, boolean, date. Data constraints. Specifies rules that data must adhere to, example minimum/maximum values, allowed values, regular expressions. Data quality expectations. Defines the expected quality of the data, including accuracy, completeness, and timeliness. This might include metrics like percentage of missing values, data freshness requirements, and acceptable error rates. Metadata. Provides information about the data source, owner, contact information, and versioning. Versioning policy. Specifies how the data contract will be versioned and how changes will be communicated to consumers. Asterisk validation rules. Asterisk defines the validation rules that will be used to ensure that data conforms to the contract. Asterisk error handling. Asterisk describes how errors will be handled when data violates the contract. Asterisk documentation. Asterisk clear and concise documentation explaining the purpose of the data, how to use it, and any relevant caveats. Approaches to implementing data contracts. Asterisk. There are several approaches to implementing data contracts, each with its strengths and weaknesses. 1. Formal schema definitions, JSON schema, Avro, protocol buffers. Asterisk pros. Asterisk machine readable, supports automated validation, enables code generation, facilitates schema evolution. Asterisk cons. Asterisk can be complex to write and maintain, requires specialized tooling. Example, JSON schema. Python example using the JSON schema library to validate data. Asterisk. 2. Database schema definition, DDL statements. Asterisk pros. Asterisk enforces data types and constraints at the database level, leveraging existing database infrastructure. Asterisk cons. Asterisk tied to a specific database technology, less flexible for non-database data sources. Example, PostgreSQL DDL. This DDL statement defines the schema for a user's table in PostgreSQL. It specifies data types, constraints, example not null, unique, check, and default values. The database itself enforces these rules, acting as a data contract enforcement mechanism. 3. Code-based validation, custom functions, libraries. Asterisk pros. Asterisk highly flexible, allows for complex validation logic, can be integrated into existing code bases. Asterisk cons. Asterisk requires manual implementation, can be more difficult to maintain and test, less standardization. Example, Python. 4. Data catalog and metadata management tools. Asterisk. Asterisk pros. Asterisk centralized repository for data contracts, facilitates data discovery and governance, provides a single source of truth for data definitions. Asterisk cons. Asterisk requires investment in specialized tooling, can be complex to set up and maintain. Examples include Apache Atlas, Alation, Collibra, Amundsen. These tools often allow you to attach schemas, quality rules, and ownership information to datasets, effectively acting as a central location for data contract information. Data contract enforcement. Asterisk. Once a data contract is defined, it's crucial to enforce it. This can be done at various stages of the data life cycle. Asterisk data ingestion. Asterisk validate data as it enters the data pipeline. Asterisk data transformation. Asterisk ensure that data transformations adhere to the contract. Asterisk data storage. Asterisk enforce data types and constraints in the database. Asterisk API endpoints. Asterisk validate data sent and received through APIs. Asterisk monitoring and alerting. Asterisk monitor data quality metrics and alert when violations occur. Versioning data contracts. Asterisk. Data contracts, like any software component, need to be versioned to handle changes and ensure compatibility between producers and consumers. A common approach is to use semantic versioning, major.minor.patch. Asterisk major. Asterisk incompatible changes to the contract, example removing a required field. Asterisk minor. Asterisk backward compatible changes, example adding a new optional field. Asterisk patch. Asterisk bug fixes or minor improvements that don't affect compatibility. Data contracts experts panel AMA. Let's simulate an Ask Me Anything session with a panel of data contract experts. Panelists. Asterisk. Asterisk Alice. Asterisk data engineer specializing in data quality and validation. Bob data architect focusing on data governance and metadata management. Carol data scientist passionate about data reliability and reproducibility. Questions from the audience Q1. How do I convince my team that data contracts are worth the effort? It seems like a lot of extra work up front. Alice that's a valid concern. It does require initial investment. But think of it as preventive maintenance. The time spent defining a data contract upfront pales in comparison to the time you'll save debugging data pipelines, fixing data quality issues, and dealing with downstream consequences of bad data. Start small, pick a critical data source, and demonstrate the value of a well-defined contract. Show them how it reduces errors and improves data pipeline reliability. Calculate the cost of data-related incidents to highlight the return on investment. Bob I'd add that data contracts also improve collaboration. They provide a common understanding of the data, reducing misunderstandings and facilitating communication between producers and consumers. They also are essential for data discovery. Imagine someone new on the team trying to use a data set. Without a data contract, they're flying blind. A well-documented contract provides the necessary context and guidance. Carol as a data scientist, I've definitely seen the positive impact. When I have a data contract, I spend less time wrangling data and more time building models and extracting insights. It's about faster iteration and more reliable results. Inaccurate data leads to inaccurate models, which can have serious real-world impacts. Data contracts help mitigate those risks. Q2. What's the best way to handle schema evolution in data contracts? How do I ensure backward compatibility? Bob versioning is key. Use semantic versioning, major.minor.patch, to clearly communicate the nature of changes. Whenever possible, strive for backward compatibility. This often involves adding new optional fields. Consumers who don't need the new fields can continue to use the existing schema. Using default values for new fields. If a consumer doesn't provide a value for the new field, a default value will be used. Deprecating fields instead of removing them immediately. Give consumers time to adjust to the changes before removing a field entirely. Providing transformation logic. Offer tooling or functions to help consumers migrate from one schema version to another. Alice in addition to versioning, provide a migration path for consumers. Consider using technologies that support schema evolution, like Avro. Avro schemas are serialized with the data, allowing consumers to use different versions of the schema to read the same data. Also, communicate changes clearly and proactively. Don't just change the schema and hope everyone notices. Use email, release notes, or a dedicated communication channel. Carol from a consumer perspective, I appreciate clear communication about schema changes. If a field is being deprecated, tell me when it will be removed so I can plan accordingly. Provide examples of how to adapt my code to the new schema. Q3. How do I choose the right schema definition language, JSON schema, Avro, protocol buffers, for my data contract? Alice it depends on your use case. JSON schema is a good choice for simple data structures and APIs. It's widely supported and relatively easy to learn. Bob Avro and protocol buffers are better suited for high-performance data serialization and data streaming scenarios. They're more efficient than JSON schema and offer better support for schema evolution. Protocol buffers excel in gRPC communication and have strong language support. Avro is often used with Apache Kafka and Hadoop. Carol * consider the tooling and libraries available for each schema definition language in your preferred programming languages. Ease of use is important. If you're primarily working with Python, a language that has excellent tooling for JSON schema is a good choice. If you're focused on gRPC microservices, protocol buffers might be a better fit. Q4, what are the best practices for documenting data contracts? Bob * good documentation is essential. Your data contract documentation should include a clear description of the data's purpose and meaning. A detailed schema definition, including data types, constraints, and descriptions. Information about data quality expectations, accuracy, completeness, timeliness. Contact information for the data owner or responsible team. Versioning policy and change log. Examples of how to use the data. Any relevant caveats or limitations. Use a data catalog or documentation platform to store and manage your data contract documentation. Tools like Confluence, Read the Docs, or dedicated data catalog platforms can be helpful. Alice * don't just focus on technical documentation. Explain the business context of the data. Why is this data important? What problems does it solve? Who are the key stakeholders? The more context you provide, the easier it will be for consumers to understand and use the data effectively. Carol * from a consumer's perspective, providing examples of how to query or process the data is invaluable. Include code snippets or sample queries to help me get started quickly. If there are any known issues or limitations, document them clearly. Transparency is key to building trust in the data. Q5, how do I handle data quality issues that violate the data contract? Alice * establish a robust monitoring and alerting system. Monitor data quality metrics regularly and trigger alerts when violations occur. Define a clear escalation process for handling data quality incidents. Bob * consider using data quality tools to automate the monitoring and validation process. Tools like Great Expectations or Deque can help you define and enforce data quality rules. Carol * implement a feedback loop between data consumers and data producers. Encourage consumers to report data quality issues and provide feedback on the data contract. Use this feedback to improve the contract and address any underlying data quality problems. Make it easy to report issues. Q6, are there any open source tools that can help with data contract implementation? Alice * absolutely. Here are a few. Great Expectations * a popular data quality framework that allows you to define and validate data expectations. Deque * a library from AWS for data quality validation in Spark. JSON Schema Validator * a Python library for validating JSON data against a JSON schema. Avro / protocol buffers libraries * libraries for working with Avro and protocol buffers schemas in various languages. Amundsen * an open source data discovery and metadata platform that can be used to manage data contracts. Bob * look at Apache Atlas, too. It can act as a central repository for your data contracts and manage the metadata and lineage. Carol * don't underestimate the power of basic unit testing in your data pipelines. Write tests to validate data quality and ensure that your transformations are correct. Conclusion * Data contracts are a powerful tool for improving data quality, reducing data engineering costs, and enhancing data trust. By defining clear expectations about the structure, types, and quality of data, you can build more robust and reliable data ecosystems. The implementation strategy should be tailored to your specific needs and tech stack. By prioritizing versioning, documentation, and proactive communication, you can ensure that your data contracts are effective and maintainable over time. Remember the expert's advice: it's an investment that pays dividends in the long run. Remember to continuously evaluate and adapt your data contract strategy to meet the evolving needs of your organization.